Alright, today we're going to look at solving right triangles, and when I ask you to solve a right triangle, it means I want you to find all the side lengths and all the angle measures. So we're looking at 6 pieces of information because you've got 3 interior angles and 3 sides. And so you're going to use all of the methods that you've learned and everything you know about triangles to do so. So you might be using Pythagorean theorem, you might be using your 30, 60, 90 or 45, 45, 90 formulas. You might be using your trig ratios, all that good stuff. So if we look at this problem here, I know 2 of the angles already. The angle at Q is 90 degrees and at R is 37 degrees. Well, you know that 3 angles in a triangle add up to 180. So all I got to do is subtract those 2 angles from 180 degrees, and that leaves me with 53 degrees. Now I've got all the angle measures found. Now I have to find the side lengths. Well, I only know one side. The hypotenuse is 22. So I can't use the Pythagorean theorem. It's not a special right triangle where it's 30, 60, 90 for the angles or 45, 45, 90. So now I'm going to use my trig ratios. Let's say I find this side first, PQ. I'll call it X. So I'm going to pick a reference angle. The 37 or the 53 will work. I think I'm going to choose 37 just because I like that one. And now I have to figure out which trig function am I going to use to find that side. So looking at my SOHCAHTOA, let's see, the side I'm trying to find is my opposite leg. Then across from the 90, that's my hypotenuse. So opposite hypotenuse, I want to use sine. So sine, angle measure always comes next, of 37 degrees, our reference angle, equals the opposite leg over the hypotenuse. And then, just like before, we put it over 1, we cross multiply. So x equals 22 times the sine of 37 degrees, and that comes out to approximately 13.2 units. Now, I'm going to go ahead and label that. I know 2 of my side lengths. I just have to find the third one. So you have a couple options here. You could use the Pythagorean theorem, or you could use a trig ratio again. It's totally up to you. I think I'm just going to go ahead and use a trig ratio. This time this is the adjacent leg, and I could use the opposite leg and I'd have tangent, or I could use the hypotenuse here and I'd use cosine. I think I'll do that. So it's totally your choice. So cosine 37 degrees. So if I'm using cosine, I'm doing the adjacent leg divided by the hypotenuse. So I'm doing y over 22. And then again, put it over 1, cross multiply. So I'm going to take 22 times the cosine of 37 degrees. Let's make sure your calculator's in degrees. And you're going to get 17.6. Now, if you use the Pythagorean theorem, you'll get the same thing. It's totally up to you what methods you want to use to solve. So there's an example where I give you 1 side length and 2 of the interior angles. Let's look at this example, because now I give you 2 side lengths, the legs, and I just give you the 1 interior angle. Well, the first thing I would probably do here is find the last side using the Pythagorean theorem. I have a right triangle. I know 2 of the sides. I can use the Pythagorean theorem to find the third side. So when I do this, I'm going to do 11 squared plus 18 squared equals x squared. I get 121 plus 324 equals x squared. Then I'm going to go ahead and add that left side together. I get 445 equals x squared. And then we know to undo a square, we're going to square root that 445 on both sides. We've got to do that. And we get 21.1 to the nearest 10th. Okay, so now I found all 3 side lengths. Now we got to go and find the other 2 angles that are missing. Well, I only know 1 angle. So let's say next I want to find angle N. I'm going to go ahead and take the X off of here. And I could go ahead and put the 21.1 on here as well now. Alright, so to find N, we're going to use one of our trig ratios. Since I know all 3 side lengths, I can use any trig ratio I want. So let's say I do sine. Sine of N degrees. Well, for sine, I'm doing opposite over hypotenuse. So I would have 11 over 21.1. Now, if you recall, whenever we're finding an angle measure, we've got to cancel that sine with arc sine or inverse sine, and that's sine to the negative first. So in your calculator, you're going to hit second sine 11 over 21.1. and you're going to get approximately 31.4 degrees for angle N. So I'm going to put that in here. Well, now that's easy because once you know two of the angles, we know that in a triangle, the angles always add up to 180 degrees. So just subtract 90 and 31.4 off of 180, and angle P has to be 58.6 degrees. Now I have all three angles, I have all three sides, and I'm done. I've solved the right triangle. Okay, I just wanted to go over a story problem with you because I know that usually we struggle more with those, and so hopefully seeing an example will help. It says you're in a hot air balloon that's 600 feet above the ground. So you can see that that's labeled, and here you are in the hot air balloon. You can see two people. So you have somebody here at B you can see and somebody here at C. This question says, if the angle of depression from your line of sight to the person at B is 30 degrees, how far is the person from the point on the ground below the hot air balloon? So we're looking at person B. We want to know how far is person B from the point on the ground below the hot air balloon. So we're looking for that length. So really we're looking at just this triangle. Now, angle of depression. So really you're looking out this way, and actually let me change colors here. They're saying that you're looking out right here at this line. And it says the angle of depression. Well, angle of depression is like when you're declining or looking down, depression, you know, it's going down. So they're saying that from here to here, that angle of depression is 30 degrees. Now, could you find this angle for me inside my triangle there, my red triangle? Well, we know that we've got a right angle here in the corner, and so if I take 90 minus the 30, that gives me 60 degrees here. Also, using our alternate interior angles, that angle is also 30. Or you could take 180, subtract 90, subtract 60 to get that third angle as well. So now, all we got to do is find x. Well, let me redraw it for you. That might help. This is 600. This is 60, 90, and 30. And we're looking for this. Well, I see a 30, 60, 90. I see one of my special right triangles. I'm going to go ahead and just use that. And so I know in a 30, 60, 90 that the long leg, which is what I'm looking for, equals the short leg times root 3. Well, my long leg is x, my short leg is 600, so my answer is 600 root 3. And let's go ahead and round that to the nearest tenth. And so when you take 600 root 3 in your calculator, you're going to get approximately 1,039.2 feet. Okay, I could have also used a trig ratio to do that. That would have been fine. Pythagorean theorem, no, because I only knew one side length. So, all right, so when you're solving a special right triangle, find all three angles, find all three sides using every single thing you know about triangles.